Domain and range, can somebody tell me just big picture, what's domain? X. All right, so if domains are the x's, we know that the domain on this is going to come from time in days. And I'm gonna go ahead and take out at the same time, I'm gonna say, we know it's gonna have something to do with X right there. Okay, then for the range, that leaves us with, that must be something about the Y's. So if the range has to do with the Y's, that in this story problem is gonna have something to do with the road length in centimeters. Okay, then a construction crew lengthened a road. It took 40 days. The graph shows the total length of the road in kilometers versus the time in days. So if our domain is about the X, what is the smallest X value that's been plotted? Like, what's the coordinate here? You go right or left 0 up 60, right? 0, 60. This is 10, 90. This is 20, 120. We use 0, something. We use 10, something. So what's the smallest the X could be? What do you think? What's the smallest the X could be? 0, okay. Now, how far over should I go? What's the biggest the X could be?
40.
There we go. So we're gonna have here, this is gonna go from 0 to 40. I mean, right off the X-axis. And now our alligators, like some Pac-Mans here, it's eating the bigger one, the bigger one. So in here, our number X, it could be bigger than 0 or it could be equal to 0. So we're gonna have less than or equal to. And then here, 40 is as big as it gets, so the Pac-Man's gonna be eating the 40. And these are going the same direction. Okay, so our X is sandwiched between 0 and 40, and we have less than or equal to and less than or equal to. Okay, so for the range, we're looking on the Y-axis. So if we're looking on the Y-axis, what is the Y coordinate? Like if we start plotting points, X, Y, what's the smallest Y for the points on this graph? 60, good, because this is 0, 60. And then this one here is at 40, 180. We're never gonna have a point that has a Y coordinate bigger than 180. So just highlighting that, we're going from 60 up through 180. So I'm gonna have 60 up through 180. And our Y's are gonna be bigger than the 60 or equal to it, and they're gonna be smaller than or equal to the 180. So just notice I'm looking at the X-axis for my domain, and I'm looking at the Y-axis for my range. So here's another one. Okay, knowing again that the domain is gonna have something to do with the X, and the range is gonna have something to do with the Y. For my X's, it's gonna be about time, and my range, my Y's are gonna be about the flour in grams. Okay, so time. What's the smallest amount of time in this one? Good, 0. Okay, and then it's gonna go through, when am I gonna stop? 12. Okay, so my X's are gonna be between 0 and 12. And then Pac-Mans are coming along here. 0 is the smallest one, X is bigger, 12 is bigger. So we're eating bigger, 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 or equal to. So we've got our inequalities in there. Okay, so for our range, what is the lowest that we can go for the grams of flour? Could you have a negative amount of flour? Okay, could you have 0 flour? Yeah, just don't have any, right? Okay, what's the most we could go to? Okay, looking at that picture, gonna go up to 900. Okay, so the lowest through the highest, so this is gonna be from 0 through 900, coming off the y-axis. And then it's getting bigger, 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 so the Pac-Mans are eating the bigger one, and it could be 0 or it could be 900, so the underlines. Okay, so here's one more, last example. So for domain and range, okay, so for my domain, that's gonna come off of the x-axis, and the range is gonna come off of the y-axis. This one looks a little bit different because we have an arrow. But thinking about our domain being the x and the range, whoops. The domain is the x and the range is the y. What's the smallest that the radius could be? 0, nice job. And then what could it be? How big a circle could you make? I could have a radius of 28. I could have a radius of 1,000. I could have a radius of 1,000,000, right? You can make a circle with as large a radius as you want. So our radius is going to be bigger than or equal to 0. X isn't stuck between two numbers this time. It's just 0 and larger. See how it goes? This graph goes forever to the right. So our domain goes forever to the right. So our x's are going to be greater than or equal to 0. Okay, so if we're making our radius bigger than or equal to 0, and our range is the circumference, what's the smallest the circumference could be? 0, because the lowest this is at 0, and then it goes up. See how it goes up forever? Okay, so we're gonna have a circumference that is bigger than or equal to 0. So right here, I'm gonna have greater than or equal to 0. I don't have a nice graph drawn for this one, but let me just show you one more just to make sure you'd have this down. What if I had an x-axis here, y-axis here, and then let's say that this started up at 10 for some situation, and then I had a solid dot there and an arrow heading up. This down here, of course, would be 0. So for my domain, what would my domain be? See how these points, this has an x-coordinate of 0, x-coordinate of 1, x-coordinate of 2, goes on forever. So this one would be my x's are greater than or equal to 0. Okay, but how about the range? What's the lowest this can go? Yeah, 10. So it's gonna go 10 and up forever. So my range on this one would be my y is greater than or equal to, oops, not 0, sorry, 10. Because all those points, the lowest it ever is 10, and then it goes up forever. Okay, that looks good.